Hey guys, how's it going? Mr. Dorado here with another video on your chapter 5 unit. Okay, so we're still talking a little bit about systems of equations, and we're going to learn today actually a new method of solving these systems of equations. Okay, so previously we were talking about graphing. Now we're going to be learning a new method called substitution. Okay, but in order to kind of see the similarities between both of them and to analyze why we can solve in both of these different ways, let's go ahead and practice with the method that we already know how to do, which is graphing. So what I'm going to do, I'm going to go ahead and take this first equation, which is kind of nice because it's already in slope-intercept form. Okay, I already know my m, which is my slope, and in this case it's negative 1 over 1. My b is 0, comma 1. So I'm going to go ahead and graph that. So that would be right there, and my slope goes down 1 to the right 1, down 1 to the right 1, and so on and so forth. Okay, same thing, but now I'm actually going to go up 1 into the left 1 to continue my pattern for my graph. Okay, and I think that's enough points there. I'm just going to go ahead and try to make as straight of a line as possible. And obviously, I stink at making straight lines without a straight edge. So hopefully you guys can do a better job. Okay, but at least my guided points there will help us identify our solution. So now this next equation in our system is not in slope-intercept form. Okay, so what we want to do is go ahead and try to figure out what that slope-intercept form would look like. Okay, so I have x minus 4y equals 16. All right, I want to get the y all by itself, so I want to isolate my y by subtracting x on both sides. Okay, so I get negative 4y equals negative x plus 16. Finally get rid of that negative 4 by dividing by negative 4, and we get y equals 1/4 x minus 4. So hopefully you guys got something similar. Alright, so let's actually go ahead and graph that line. So starting at negative 4, which is right down here, I'm going to go up 1 to the right 4, up 1 to the right 4, and from that second point I graphed on there, I'm sure you guys can already start to see what my solution will be. So if I graph that, so much better. Okay, but now we can actually see our point of intersection, and as you guys can see, that would be the point 4, comma, negative 3. Okay, so the solution to this system is 4, comma, negative 3, meaning if I were to actually substitute those x and y values into my original system, it would give us a true statement for both situations. Okay, so what we want to do now is actually take that into consideration, but now let's use a different method to see if we get a similar answer if we use this new method. Okay, so what this new method is called is substitution. Okay, so let's go ahead and figure out what substitution tells us to do. All right, so again, it's a solve by substitution, and they give us the same set of equations in our system. But if you guys notice here, this y is already all by itself, and it's telling us that y equals negative x plus 1. Okay, nothing different. That was just the original equation we got. But if you start to think about it, okay, well, if y is this negative x plus 1, then why couldn't I just substitute that negative x plus 1 in there? Okay, and that's exactly what you see in this new equation. All I did was take that y, and instead of putting a y, I'm going to go ahead and put a negative x plus 1. Okay, so let's go ahead and distribute that out. So if I were to distribute this negative 4 here, what would I get? Well, plus 4x minus 4 equals 16. Okay, So that now notice that we only have x's here. Okay, that's kind of nice because if we can figure out what x is, then we can go back and figure out what y is. So let's go ahead and figure this out. So I have two like terms here that I can combine. So this is a 5x minus 4 equals 16. I'm going to add 4 to both sides. And then I'm actually going to go ahead and work up here. So that is 5x equals 20 divided by 5 divided by 5. And we get x equals 4. So in my order pair for my solution, okay, because we know our solutions are usually order pairs, okay, then we're going to have a 4 here. And if you guys can already tell from the previous answer that we got when we graphed it, we also had a 4 for our x value. So now what we're going to do is take that 4 as our x value and substitute it back into the one of the equations in our system and see what our y value will be, okay? And if we are agreeing that both graphing and substitution will give us the same answer, then we should see -3 as our y value when I substitute that back into an equation. So let's go ahead and figure that out. Let's go ahead and try it. So I'm actually going to go ahead and just make myself some little room here to work with, okay? I'm going to go ahead and use this original equation up here. I'm going to use this one right there in order to find my y value. But now I'm going to write y equals negative. I know my x now. That's just a 4 plus 1. Okay, well, we know what -4 plus 1 is. That's a -3. And look at that. We have completed our solution set, or our solution point, okay? And that is exactly the same point as the original one we had in the previous problem. Okay, notice those two are exactly the same now. Okay, now we have again another method in our belt in order to figure out the solution to these systems. Okay, so what we did here is this. Okay, we figured out which variable was easiest to isolate. Okay, if we notice in our original problem, the y was already all by itself. It already gave us y equals something. Okay, the bottom equation wouldn't really work because it says x minus 4y equals 16. The thing that's all by itself is a number, not a variable. So that's why we chose the original top equation, y equals -x plus 1. Part 2 says get the variable alone and put the quantity it is equal to in parentheses. Okay, so we did that. That -x right here, that -x plus 1, okay, we substituted that into one of the original equations. With that, we were able to do step 3, which is substitute that quantity in for the variable and into the other equation. Okay, now again, that does seem like a lot of stuff, guys. Don't get overwhelmed by it. Let's just go ahead and keep practicing, and we will be able to understand it as we go along. Okay, so let's go ahead and continue with two more of these problems, and then I'm going to have you guys try one on your own. So ask yourself again the same question as earlier. Which of these variables is already solved by itself? Okay, so the top equation or the bottom equation? Okay, well, I hope you said the top equation because look, it says that y equals all of this. So, excuse me, what I'm proposing here is that, okay, if y equals all of that, then why can't we just put all of that in here where this y is? Okay, so that's exactly what we're going to do. So let's go ahead and do -3x plus 4 parentheses. Now this I'm going to put in there. Okay, so this would be 7x plus 8 equals -18. All right, now we just have to distribute a little here. So we would get -3x plus 4 times 7x is a 28x. 4 times 8 is a positive 2 equals -18. I can combine a few like terms here. I can combine those two. So I get 25x plus 32 equals negative 18. Finally here, I'm going to subtract my 32 to get 25x equals negative 50. Final step. Okay, so I get negative 50 divided by 25. I get x equals negative 2. Okay, so I have my x portion of my solution. Now it's just up to us to go ahead and find the rest of it. Okay, so in order to find what my y is, we're going to have to use one of the original equations to substitute that x back into. Okay, well, I'm actually going to go ahead and use that first equation. Okay, it's that y equals 7x plus 8. I'm going to use that equation, the first one. But now I know my x, so I'm going to go ahead and write y equals 7 parentheses negative 2, because that's what my x is, plus 8. Okay, well, with a little multiplication here, I get negative 14 plus 8, and that would just give me a negative 6. So my final portion here would be negative 6. Okay, so this right here is my final answer. The solution to this system is negative 2 comma negative 6. All right, so I think you guys should have enough of information here to try out number 2 on your own. So why don't you guys go ahead and pause the video right now and try out number 2. Alright guys, so hopefully you guys had a chance to try out number 2. Again, first thing you should ask yourself is, what variable is already solved all by itself in number 2? Well, if you guys can see the first equation, x equals 5y, they're already telling us what x is. They're telling us that x equals 5y. So why can't I just put that 5y there? Well, there's nothing holding us back, so let's go ahead and do it. So that would be 3 times, and now instead of an x, I'm going to put a 5y plus 2y equals 34. Okay? And just for a second, guys, I want to stop for a second. Again, the reason why I'm substituting in there is because look at my new equation. Okay, I only have y's here. There's no more x's. That means I can solve for that variable y, and then finally come back and solve for x. Okay, so in the meantime, let's go ahead and continue solving this. So this is 15y plus 2y equals 34. These two are like terms. I can combine those to get 17y equals 34. Final step here is to divide by 17. So we have y equals 2. Okay. Now, that was our y, so be careful where you place it in your solution. That goes there. Whoops, not negative 2. Sorry about that. Just a positive 2. All right, now it's up to us to figure out the rest of it. Well, again, use one of your original equations to substitute that 2 in for y. I'm going to go ahead and use that top one because it looks like the easiest. So this is what it originally looked like, but I know my y now. So this is going to be x equals 5 times 2. So this is really x equals 10. That is the second portion that I needed in order to finish solving. So my final order pair is 10 comma 2. All right, so hopefully you guys got a similar answer for this problem. And now we are ready to go on to problem number 3. Now, again, let's go back to our original question. Which one of these is already solved for one of its variables? Well, if you notice, none of these are. Okay, we have a 2x plus 2y equals 3 and an x minus 4y equals negative 1. None of them already say x equals this or y equals that. Okay, so what we want to try to do here is try to pick one of those equations to try to get one of those variables all by itself. And I'm going to go ahead and pick one right now, and I'll show you why I picked it. Okay, the one that I'm going to pick is the bottom equation, which is x minus 4y equals -1. And the reason I chose that one is because, look, the coefficient in front of the x is a 1, okay, so that's kind of nice. The coefficient in front of that y is a -4. Well, that's a little bigger, and I honestly don't want to be messing around with negatives. And so because the x is kind of nice already all by itself, or it's kind of nice already, I'm going to try to get it by itself. And I'm going to do that by adding 4y to both sides. So let's see what I have now. This is x equals 4y minus 1. Well, look at that. This is essentially that equation rewritten. Now I have two equations, one equation, two equations. So that is my system. Now number 3 looks almost identical to number 1. Okay, I have one of these variables already solved, which is that x. Okay, I have x equals 4y minus 1, so I can start doing my substitution. Well, let's go ahead and do it. So I have 2 parentheses. Now I can put that in, which is 4y minus 1 plus 2y equals 3. Again, notice how now I only have y's. So I'm going to distribute. I get 8y minus 2 plus 2y equals 3. I can combine these two terms here. So I get 10y minus 2 equals 3. Let me add this 2 here. So I get 10y equals 5. Final step, divide by 10. So we get what? We get y equals 1/2. Well, that was only part of it. That was our y. Okay, and I apologize, the solutions kind of went to the second page, but anyways, the solution here is something comma 1/2. Okay, so something comma 1/2. So let's figure out that other part of it, which is my x value. So what I'm going to do is go ahead and substitute that y into one of my original equations. Okay, I'm going to go ahead and do it to that top one. So I'm going to do 2x, and I'm going to kind of separate this so I don't start getting confused here. Okay, so that's 2x plus 2. Now I know my y, which is 1/2, equals 3. So what I get? I get 2x plus 1 equals 3. I'm going to subtract my 1. I get 2x equals 2 divided by 2. So I get x equals 1. So my final answer here is 1 comma 1/2. All right. So again, my solution there is 1 comma 1/2. That is a solution where my x and y, I can go ahead and substitute those two values into both of these equations, and I will always end up with a true statement. Okay. All right. I'm going to have you guys go ahead and do number 4 on your own. What I'm going to do is help you out getting started. Okay, I'll give you guys a really huge hint here. But honestly, you could have gone another route, but I'm gonna go ahead and choose one and help you guys with it. Okay. All right, and then I'm gonna let you guys run with it and complete the rest of it. So we have y minus x equals -4 and 4x plus y equals 26. Well, again, none of those are already solved or all by themselves, so why don't we go ahead and just choose one? I'm going to go ahead and choose this top one. And again, the reason why I'm choosing it is because, look, if the y was all by itself, it'd be kind of nice because it's already a coefficient of 1. So what I'm going to do is get rid of this x here to get y equals x minus 4. I now have one equation, two equations. That is just, or I should say, this equation here is just that equation rewritten. But now this becomes just like the rest of our problems. Okay? So why don't you guys go ahead and pause the video right now and try out number 4. Alright guys, let's go ahead and make sure that you guys did this correct. So let's go ahead and solve the system. So let's go ahead and substitute in our new x value, or I'm sorry, our new y value. So this is 4x plus my new y we said is a x minus 4 equals 26. Well, that plus is not really going to change anything, so I don't need those parentheses anymore. However, here I can combine those two to give me 5x, and then add my 4 to both sides. We get 5x equals 30. Whoops. Divided by 5, divided by 5. So we get an answer of x equals 6. Okay, so we get x equals 6. Now I can go ahead and substitute that back into one of my original equations. Alright, so I'm going to go ahead and do the same thing. I'm going to go ahead and plug it back into one of my original equations. Okay, so I'm going to go ahead and choose, it honestly doesn't matter, but I'm going to go ahead and choose this one right here. Okay, even though it's rewritten, it essentially is one of the original equations. But again, it doesn't matter. You can actually go ahead and substitute it in here and we'll get the same thing. Okay, so let's go ahead and use one of those. So I'm just going to use this one right here. So this is y equals, now instead of an x, I'm going to put a 6 minus 4. So we get y equals 2. So what's my final answer? Well, my x was 6, my y was 2. So my final answer is 6, comma 2. All right. So essentially 5 through 10, same thing. We're just substituting here, guys. So let's go ahead and do, I would say let's go ahead and do number 5 together and maybe number 8. I'm going to go ahead and skip 6 and 7. I want you guys to try those on your own when you get a chance. But for now, let's go ahead and do number 5 together, okay? So again, ask yourself the question, which one should I solve for? Or rather, which one is already solved all by itself? So which variable is all by itself? Well, this y is all by itself. Y equals that negative x plus 4. So I'm going to go ahead and substitute that y into that other y. Okay, so what do we get? We get negative 3, and instead of a y now, it's a negative x plus 4 minus 3x equals negative 2. All right, let's do a little distributing here. So we get positive 3x minus 12 minus 3x equals negative 2. All right, well, right off the bat, we're starting to see something a little strange. So let's go ahead and figure out what we can do here. Those two cancel out. And what do we get? We get negative 12 equals negative 2. Okay, I can't really do much here, but let me ask you guys this. Can that happen? Okay, is that true? Is negative 12 equal to negative 2? I hope you guys are saying no, and you would be right. No, those two are not the same. Okay, so this system actually looks like it's not going to have a solution. Okay, so I would say here in solution, no real solution, or just no solution. Okay, if you start to think about it, actually more graphically, and like if you guys go back to when we were doing graphing, solving by graphing, this would mean that these two lines are actually parallel. Okay, so in this case we have a situation where we have no solution. Okay, but double check your work, make sure we did this correct. Okay, we substituted correctly, and it looks like we have still negative 12 equals negative 2, which is not true. Okay, so why don't we go ahead and do number 8? Okay, and just to kind of continue talking about this special scenario where we have no solution, if you ever ended up with something that said like 3 equals 3, that would be all real solutions, meaning it's the exact same line. It's just basically on top of each other. Okay. All right, so let's go ahead and take a look at number 8 here. Number 8 looks, it's not necessarily a special case, but it is kind of special. So let's go ahead and see. Again, ask yourself which variable already is set equal to something else. We'll notice here that x equals all of that, but this x also equals all of that. Okay? Well, if those two things are equal to x, then they must be equal to each other. So I can set this up as 4y plus 5 equals 3y minus 2. Alright, so let's continue solving from there. So I'm going to go ahead and subtract 3y. Remember, always move the smaller variable first. So this is y plus 5 equals negative 2. Subtract my 5 to get y equals negative 7. Okay, so that is the y portion of my solution. So, whoops, not 0. We don't know what x is yet. So it's just something comma negative 7. Okay, so but now I can go ahead and substitute this back into one of my equations. I'm going to go ahead and substitute it into this first one here. So let's see, we get x equals 4 parentheses negative 7 plus 5. Well, what is that? That would be negative 28 plus 5. So we get x equals negative 23. So my x order pair is negative 23 comma negative 7. Again, guys, if you're not convinced that you can substitute it into any of these equations, I strongly suggest that you try out another one, okay? So if you didn't want to substitute that negative 7 into this top equation here, do it to this one down here. You'll get the same thing. Watch. X equals 3 times negative 7 minus 2. What is that? That's negative 21 minus 2. That is still x equals negative 23. Again, same exact answer. So it doesn't matter which one you substitute it back into. Okay, so let's go ahead and keep going. Number 9 is actually a very similar problem to number, whoops, let me scroll up, to number 8. So I would suggest that you guys actually go back and try those out and see how well you do. Okay, so go ahead and try out number 6, 7, and 9 on your own and see how you do on those. Go ahead and pause the video at this time and try those out, and we'll come back to verify that number 9 and number 10 are complete. Okay, so guys, for the sake of time on this video, I'm going to go ahead and skip the solutions for 6 and 7. Okay, but we're going to go ahead and take a quick look at number 9 and number 10 in order for us to finish up the video on time. So number 9, very similar to number 8. So they're telling us that y equals all of this, but also that y equals all of that. So because y is equal to both of those, then both of those things must be equal to each other. So we have 2x plus 3 equals 4x plus 1. I'm going to go ahead and subtract 2x. So what do we get? We get 3 equals 2x minus 1. Let's add 1 to both sides. So we get 4 equals 2x. Finally, divide by 2. So we get a final answer of x equals 2. So part of my solution here is going to be 2. Now I just need to find out what y is. And then remember, just like I proved to you on number 8, you can plug that 2 back into any of these equations. So I'm just going to go ahead and do it to the top one. So this would be y equals 4 plus 3 for a final answer of 7. So my ordered pair is 2, 7. So verify that you guys got a similar answer on number 9. Okay, and since you guys again already tried out number 10, I'm going to go a little bit quick on this one. So let's go ahead and ask ourselves again, which of these variables is already solved all by itself? Okay, well, it's this y. Y equals all of that, so I can substitute that in here. Now I want you guys to be very careful here when you're substituting and when you're distributing. So if I substitute it that way, it's going to be 2x minus, and remember, this whole thing has to be in parentheses. It's going to make sense why in a second. Okay. The reason why it has to be in parentheses is because I have to distribute that negative to both of those terms. Okay. So this would be 2x minus 3x plus 9 equals negative 4. If you had forgotten to do that, guys, you might end up with something completely different on your final answer. Okay. So what do we get here? This is 2x plus 3x. That is a 5x plus 9 equals negative 4. Subtract the 9. Okay. And then we get, let's see. Whoops. Sorry about that. We get, oh, I'm sorry. I made a quick mistake here. This is not supposed to be a 5x. This is supposed to be a negative 1x. 2x minus, whoops, let me use the different color. Sorry about that, guys. Made a little bit of a boo-boo here. Okay, so 2 minus 3, that's a negative 1, not 2 plus 3. I accidentally thought it was 2 plus 3. Okay, so then this right here becomes negative 1x equals negative 13. I don't want a negative x. I want just an x. So I'm going to divide by a negative 1. So I get a final answer of x equals 13. But now I have to substitute that back into our equations and verify if those are correct. So let me make some room here. Make sure this worked. So 2 times 13 minus y equals negative 4. That is a 26 minus y equals negative 4. Subtract the 26. That's a negative y equals negative 30 divided by negative 1 is a y equals 30. Okay, so y equals 30, so that is my last piece of the puzzle here. So my ordered pair solution is 13, 30. All right, so hopefully you guys got something similar on your answers. Okay, and then I want to finish off this video by going over number 11 and 12. Okay, so number 11 is essentially a review of what we've been doing. Okay, that was a system of linear equations. And then number 12 is also a review, but that one is a system of linear inequalities. Okay, and I do apologize for my sheet. It probably looks different than yours because the spacing was completely off, but hopefully you guys can still follow along. Okay, so number 11, remember, what is it asking? It says solve by graphing. So that means I have to graph this line, and I have to graph this line. I don't know why my red dot just went away. Okay, what's going on? I'm not sure why it's doing that, but anyways, I'll go ahead and move forward. Okay, so this first equation up top, that one is already in slope-intercept form, so I can go ahead and graph it. So I'm going to go ahead and start at negative 3. And then I'm going to go up 1 to the right 2, up 1 to the right 2, up 1 to the right 2, whoops. Okay, I do not know why it's erasing all of my lines. Or all of my dots, I should say. So I'm gonna, let's try something else. Let's try, okay. So -3, up 1, right 2, up 1, right 2, up 1, right 2, 1, right 2, up 1, right 2. Or down 1, left 2, down 1, left 2. Okay, so hopefully they'll stay and they don't go anywhere, because for some reason they were deleting right now. But that gives me my first line. Okay, that would be this one. Okay, now in red here, I'm going to go ahead and do my other one. So I start at my y-intercept of 0, 2. That would be right there. So I'm going to go, and this is my slope, 3 over 1. So rise of 3 to the right 1. Rise of 3 to the right 1. Or down 3 to the left 1. Down 3 to the left 1. Down 3 to the left 1. Down to the left 1. And I'm sure you guys have already spotted it. Had I actually hit it. This is taking forever. Okay, let's try it one more time. Let's try to go through that actual point. A little better, okay? But now we can see that right here is our intersecting point of both of those equations. So that will be our solution. So what is that ordered pair? That would be -2, -4. Again, guys, if you wanted to double check to make sure that really is the accurate point of intersection, then you could just substitute those values back in. Okay, so that was solving by graphing these linear equations. Okay, but now we're going to look at solving linear inequalities just like we did before. Okay, so let's go ahead and graph the first one. I'm going to go ahead and do that one in green. So again, this is already in slope-intercept form, so I can start at 0, -1. My slope is up 2 to the right 3, up 2 to the right 3, up 2 right 3, or I can actually go down to left 3, down to left 3, down to left 3. Okay, and this one is just a greater than symbol, meaning I only have to make a dashed line. Okay. All right, and then I actually have to, let's see, I'm going to go ahead and graph the other one. Actually, no, I'm going to go ahead and make my lines. It was a greater than, okay? So because it was a greater than, I'm going to have to shade above. So I'm just going to draw those lines just for reference so I know where my shaded region has to be. Okay, now in red, I'm going to do my y is greater than or equal to -1/3 x plus 2. Okay, so I'm going to start at +2. I'm going to go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3, or the exact opposite, which is up 1 left 3, up 1 left 3, up 1 left 3. Okay, I'm going to go ahead and try to connect that as best as possible. And then yet again, this one is a greater than, so it has to be shaded above. Oh, and by the way, I made it solid because it's a greater than or equal to. So that means it gets shaded. I'm sorry, that means it's a solid line. And then we can see the area where we have the shade because both the green and the blue arrows are hitting each other, which means this area here is my solution set. Okay, but that was not the question. The question was determine whether 3, 3 is in the solution set. Well, let's go ahead and find it. 3, 3 is right there. Is that in the shaded region? Yes, it is. Okay. All right, guys. Well, again, At the beginning, we did a little bit of graphing, which we have done before. We just verified that we still understood how to do it. Okay, we compared that to our new method, which is substitution. Okay, remember with substitution, always ask yourself which variable is already all by itself. Okay, is there something that already says y equals or x equals? If there is nothing like that, then remember you can always manipulate each equation to get it to that point. Almost like when you have some sort of equation and you're trying to get it into slope-intercept form. Remember, you're always getting the y equals to something else. Similar process here. Okay, so try to get one of the two equations. You can choose whichever you want, and try to get it so that it says x equals or y equals. Then at that point, you can go ahead and go back, substitute that into the other equation to find one of the values of either the x or y. And then finally, once you have that value, you can go back and actually find your remaining value. Okay, so that would give you your two values, which would be your x and your y for your ordered pair, and that in turn is your solution to that system. Okay, now towards the bottom, we just basically reviewed one more time with graphing and finally solving linear inequalities. Okay, remember how to do those. If you guys are still a little bit confused about either graphing linear equations or linear inequalities, make sure you guys watch the two previous videos from Unit 2. Alright guys, I think I'm going to go ahead and stop the video there. Hopefully you guys are gaining a little bit more of an understanding of this unit on systems. And tomorrow, or rather on the next lesson, we're going to be learning a little bit about a new process which is called elimination. And then we'll talk a little bit about how each one of these methods has their own advantage. Okay? Alright guys, well I will talk to you soon and have a good one. Bye.